on this video than I was able to do in class. So if you need some more instruction, here we go. I'm going to solve this radical equation that has two radicals in it. The very first thing that I need to do is isolate a radical, and one already is. It's the square root of 5 minus b. So I am now going to square both sides. Hold on. So when I square the square root of 5 minus b, I get 5 minus, not equal, minus b. That's going to be equal to this quantity squared. And we need to FOIL that out. And what we will get is 1 minus 2 times the quantity of the square root of 2b minus 4. My last term then will be the square root of 2b minus 4 squared, which is just 2b minus 4. So I have plus 2b minus 4 here at the end. My next step is to isolate the square root again. So I am going to bring all my terms over to the right hand side except the minus 2 square root of 2b minus 4. So I'll leave this over here on my left. And let's see, I'm going to subtract 2b, and that will give me minus 3b. And I am going to, 1 minus 4 would be minus 3, so I'm going to add, I'm going to subtract, let's see, that's minus 3, so that means I need to add 3 to both sides, and that gives me plus 8. Now, I'm ready to square both sides of my equation again, and that gives me 4 times the quantity 2b minus 4. Make this look more like a b. And now squaring this side gives me, let's see, 9b squared. And then my middle term, remember I'm squaring, so I have to FOIL it. That gives me minus 24, and then double that, that's 48b. And then my last term is plus 64. Now I am going to set this equal to 0 and hope that I can factor it. That gives me 8b minus 16 equals 9b squared minus 48b plus 64. Next, I'm going to subtract 8b from both sides and add 16 to both sides. So 0 equals 9b squared. Subtracting 8b from both sides gives me minus 56b. And adding 16 to both sides gives me plus 80. Doesn't that look fun to factor? And I sat before I made this video and I figured out what two terms are going to add, what two numbers add to 9 times 80, but add to, I think I said that wrong. I figured out what two numbers multiply to 9 times 80, but add to negative 56b. And those have to be negative 20 and negative 36. If you don't believe me, give it a try. It took me a while. So I'm going to separate my middle term into negative 20b minus 36b plus 80. Again, negative 20 times negative 36 is the product of 9 times 80, which is 720, but these two numbers add to negative 56. So that's perfect. I'm ready to factor by grouping. It gives me 9, and my common factor here of my first two terms is just b. So I end up with 9b minus 20 in parentheses. And these last two terms, my common factor is minus 4. So that becomes 9b minus 20. And then I'm going to continue to factor. That's 9b minus 20 times the quantity b minus 4. Yay! So now let's see, what's b? Well, b is either equal to 20 over 9 or it's equal to 4. But remember, when I'm solving a radical equation, I have to go back and check to see if either of these answers are extraneous. So let's see, my original equation, let me get there, is this. I'm going to move this down so I can see it a little bit better. Here, I'm going to check both of these. Don't they look fun to check? So now, first I'm going to check, what if b equals 20 over 9? I got to substitute in. That's 1 minus the square root. Oops. Oh, I do not like that. Let's try this again. 1 minus the square root. Let's get that gone. Hold on. There we go. 1 minus the square root of 2 times 20 over 9 minus 4. That's got to be equal to the square root of 5 minus 20 over 9. And that's the question. Well, let's see. That's 1 minus, let's see, 20 over 9 times 2. Let's see, 20 times 20 divided by 9 minus 4. That's 364 over 9. The question is, that the same as 5 minus 20 divided by 9, and that is 25 over 9. Notice how these are perfect squares, thank goodness. And then I find, let's see, my left is 1 minus the square root of 364 divided by 9. Let's see what that is. 364 is not a perfect square. This one does not work. But I feel like it came out a little bit nicer before. Let's see.
Yeah. It looks like that. We use that dress.
Oh yeah, here we go. This part.
It took a long time.
Let me get the right spot. Is not 364 over 9. That is actually 4/9. Let me just double check my work. 40 divided by 9 minus 4. Yeah, something happened with my calculator. That's 4/9. So the question is that 1 minus 2/3 equal to 5 over 3? And it absolutely is not. And if I check my second answer here, b equals 4, you're going to find that that one does not work either. And at that point, we're going to say no solution. And boy, wasn't that a lot of work to find out that there was not a solution to this equation. But that's how you do it. So next, we talked about this in class, use substitution. It's when you make a substitution in so that your equation looks quadratic. I just want to talk about the steps just a little bit slower than we did in class. You are going to identify the substitution, transform your equation into a quadratic equation that you're used to solving. You're going to solve the quadratic equation. You're going to apply, then after you solve it, you're going to substitute back in. You are then going to solve from there, and then you are going to check your work. So let's try one. I put a new equation in, and this one looks quadratic, but it's not quite. If I let a, and I guess I could call it u, but I like a better than u, equal x to the minus 1/4, I can substitute in, and I'm just going to show you, x to the minus 1/4 squared is the negative 1/2 plus x to the minus 1/4 minus 6 equals 0. Now do you see how you can put the a in here? So we have a squared plus a minus 6 equals 0, and that's factorable. So this factors as a plus 3, a minus 2. So I end up with a equals negative 3, or a is equal to 2. Now I'm ready to substitute back in. So I'm going to put my x to the negative 1/4 in for a. And from here, you got to remember, a negative exponent really just means it's in the bottom. So this is x to the 1 over x to the 1/4, that's equal to negative 3, or 1 over x to the 1/4 is equal to 2. So I'm going to flip both sides of these equations, and that gives me x to the 1/4 equals negative 1 over 3, or x to the 1/4 is equal to 1 over 2. Now I'm going to raise both sides to the 4th power, which means that I get x equals 1 over 3 to the 4th, 81, or x equals 1 over 16. Now, this answer right here is going to be extraneous. I already know that because I know that the 4th root, which is what this is always going to be positive. I can't have a negative like this. So I know that's going to be extraneous. But if I didn't recognize that, I would have to go back and plug into my original equation and find out that that's the case. The 1/16 will work, and that is my solution right there. Next, let's see what else. Here's another equation that I'd like to solve. I did a problem like this in class, but it was pretty quick, so I want to give you a little bit more explanation. When I factor out a common term, if I had a to the 4th minus a squared, and I wanted to factor that, most of you will recognize that I can factor out a squared right away, and I end up with a squared minus 1. But what you don't realize you're doing is you are taking the term with the lowest exponent out, and then the exponent that you're left with on the inside is the 4 minus the 2. So I'm going to do the same thing over here. We're going to take x to the 1/3 out, and then I'm going to be left with x to the 7/3, and I'm going to write this out so you can see it, minus 1/3 minus 3 times x to the 4/3 minus 1/3. Now I'm running out of room, so I better fix that. And then, let's see, minus 4x to the 1/3 minus 1/3. That's all still equal to 0. So when I do that, what happens is it works out nicely. So 7/3 minus 1/3 is 6/3, or x squared, minus 3. 4/3 minus 1/3 is 3/3, or just x. Oops, I wrote a 6 and I didn't mean to. This should have been squared. 7/3 minus 1/3 is 6/3, or 2, minus 3x minus 4 equals 0. So that turns out to be x to the 1/2, and then I factor that, x minus, let's see, x minus 4 times x plus 1, and then I solve from there. Setting each of these equal to 0, I would find out that x equals 0, or x equals 4, or x equals negative 1. And then it's always a good idea to go back and check your work. So I hope that helps. Happy homework doing, and have a wonderful weekend.